Hey everyone, so I had to come on campus to grab a few things, so I thought I'd record this lecture while I was here and in a quiet place. I hope everyone's doing well. I know it's a really weird time, but we are going to get through this and we're going to learn some regression along the way. So today I want to talk to you about moderation with categorical variables. So we'll talk about what exactly moderation is. But the learning outcomes here, understand how to perform moderation analysis, this time with categorical variables. And then we're going to talk about interaction effects, which is what happens when you do a moderation. And then be able to use process, I guess I should put stata here, also for moderation. So when we have categorical variables, just to bring you back to the very beginning when we were talking about the levels of measurement, remember we have continuous variables, which you just kind of go from one into the other, and categorical variables, which the numbers don't mean anything, they really just represent categories. So we have this plot here, this is shoe size by gender. So we can say two different types of things when we have categorical variables. We can say the means are different. So in this case, men have, on average, a larger shoe size than women. And that's what we've been doing when we've been looking at these dummy variables. Remember in our regression equations, when we have dummy variables, what we do is we interpret the intercept as the mean for the reference group, or the group that's coded 0, and then that slope, which we're calling the slope, for the group that's labeled 1, the independent variable, which would be gender in this case. That's the difference between this mean right here and that reference group, right? So if we were looking at a regression with this, we would see, maybe 7.3 for the intercept on shoe size, and then the slope for men would be like, 2.7 or something like that, to be the difference between the genders. Okay, yeah, so that's really one interesting kind of question. But another type of question you can ask is, okay, I have two variables. How do two groups differ in the relationship between those two variables? So in this case, what we have is different slopes. So these are different means, and this is different slopes. So instead of saying, does the relationship in the difference in shoe size differ by gender, or is there a difference in shoe size by gender, we could say, is there a difference in the relationship between height and shoe size for different genders? So what we might say then is that we know that the taller you are in general, the larger your shoe size is, but the men's shoe size increase at a larger rate than, say, women. They're kind of more, compact in how much their shoe size changes. That's the kind of question that moderation can answer. All right, so for official definition, moderation is the combined effect of two or more predicted variables on an outcome. So we can use both categorical and continuous variables in moderation, but I think it's easier to understand it with the categorical first, so that's why we're starting with the categorical one. So what kind of research questions can you answer with this? In what groups? What categories? Under what circumstances does an association between X and Y exist? Another way to say that is when and for whom does it exist and does it not exist, right? When does that relationship go away, and when is that relationship present? And then we can also phrase this as, does the magnitude and the direction of the relationship between X and Y change under different conditions or in different categories? So when we're thinking about magnitude, that's how sharp that slope is. When you think of direction, you can think about, is one group going to have a positive relationship and another group going to have a negative relationship? So when you have moderation, you can have all the groups or all the categories having the exact same relationship, or they can have different relationships, right? So one can have a stronger relationship, one can have a completely opposite direction. All kinds of things can happen in moderation, and that's what makes it so much fun. So let me show you what our diagram for moderation would look like. So if we were just looking at the difference in shoe size for men and women on average, we would stick with our normal regression equation that we've been looking at. This is a slope for gender, and then this is shoe size for a dependent variable. Now remember when we talked about mediation, we had our mediator variable with the relationship between the independent variable and the mediator, and then the relationship between the mediator and the dependent variable. The moderator, we draw it a bit differently because the idea is that the moderator is changing the relationship between X and Y in particular way. And I know a mediator also is changing the relationship in X and Y, so that's why you have to kind of separate in your mind. A mediator, we're trying to explain the relationship between X and Y. In the moderator, we're just saying, is there a different relationship for different levels of, or different categories of the moderator? Once I get through this and we get through the continuous variables, we'll talk about some ways that mediation and moderation really overlap and can kind of explain the same things. But right now, I want you to kind of think of them as two separate things. Mediation is, oh, we're going to explain why X is happening on Y. And then for moderation, we're just going to look for a different relationship between X and Y in different groups. Okay, so this is what our diagram for moderation would look like, where our arrow from the moderator is pointing at the arrow between X and Y. Okay, so this is what our equations would look like when we're doing a moderation. The actual calculation of what we call an interaction term or that moderation variable is really just X times your moderator. In this case, our moderator is a categorical variable, so we're doing it as a D. But this should look familiar, right? So we have our intercepts right here. We have one slope, that's one independent variable. We have another slope, this is the moderator right here. And then we have our new coefficient right here, which is going to be a slope that represents the interaction term, or the effect of the moderator times the independent variable. And just a little bit about terms. A moderator is just another word for an independent variable. When you have these moderation equations, you have two independent variables, right? One we're just going to refer to as the independent variable, and the other we're going to refer to as the moderator because we're expecting it to have, you know, this relation right here. But they're both independent variables. We just kind of give them different names so that we can keep track of what we think is happening. So I'm going to show you an example that has a dummy variable that only has two categories in it, but you can also do moderation with multi-categorical variables. And in that case, we would have our dummy variable for the first comparison, our dummy variable for the second comparison. There's our moderator right here, and then you just multiply. You have to have one interaction term for each of yours. Variables, and I'll give you an example that you can see that a little bit later. All right, so before I get to the example, let me talk through interpreting the slope and the intercepts when you have an interaction term or when you're doing moderation. Those are two ways to say the exact same thing. Most of this is going to be exactly the same as we've been doing, and this is in the steps and data analysis handout that you have. So first thing, when you interpret that intercept, when all the x's are 0, the mean of the reference group is the intercept. Okay, and that's going to be the same no matter how many dummy variables you have in your model. For our dummy variables, we're going to interpret it once again as the group that's coded 1, the difference between that group and the reference group on their mean. So this is our question of, you know, do men and women on average have different shoe sizes? This slope for that dummy variable is going to tell you that. And over here, when we have multiple dummy variables, again, it's going to be the group that's coded 1 compared to the reference group. The other group that's coded 1 compared to the reference group. That's exactly the same. For our continuous variable here, which is our moderator, we're going to be using the same thing that we've been doing before. So a 1 unit increase is going to be related to whatever that slope is, increase in y. 1 unit increase in x, slope unit increase in y. And that's going to be controlling for everything that we already have in the reference group. So this is remembering all the things we've done before with interpreting slopes. That's exactly the same. The new thing is how we interpret this interaction term. All right, so this is X times D. So this is our moderator times our independent dummy variable right here. And then in this one, since we have more than 2 groups, we have multiple dummy variables, and so we have 2 interaction terms. Now, you will get a number for these slopes, but in general, I don't try and interpret the number directly because it just doesn't make a lot of sense to me, just kind of the way I think about it. For me, I just look straight at whether or not this is statistically significant, and then I will use the plot to tell me what exactly is what's going on in the relationship. So what I will say, if this X times D, this interaction term, is significant, then I will say, okay, our moderator and independent variable interact in their effect on Y. Or once we look at the graph, we can say, okay, well, group 1 has a stronger or weaker effect of X on Y compared to group 2. Or, you know, a simple way to say it is just that there's a moderation, right? That the moderator moderates the effect of the independent variable on Y. And you can do that exactly the same for when you have multiple categories. It just gets a little more complicated when you have multiple groups, because then you have to plot all the groups onto the same graph in order to really figure out, okay, this group has this kind of slope, this group has that kind of slope. It can get fun, I will say, but the real thing to keep in mind is that the interpretation of the first part of this equation is exactly the same. The new thing that you're learning is about this interaction term. Okay, so hopefully you're not completely confused. Let's do an example to make it more concrete. Okay, so I hope that this isn't too offensive to anyone, but I just thought that since a lot of us are at home, might think about what is the effect, excuse me, on people who have to stay at home in isolation on how stir crazy they get. I've been seeing the memes, you know, you need to check on your extroverted friends. They are not okay. So maybe we can think about how, in the statistical terms, how not okay our extroverted friends might be compared to the more introverted people. So this is some fake data that I made up that looks at the amount of stir craziness over days of isolation for extroverts and introverts. So a way of phrasing our research question could be, do extroverts and introverts differ in how quickly they become stir crazy as they stay at home in isolation? All right, so there's other ways to phrase this, right? So if we went back to these kind of questions, we could phrase this, you know, is there an association between days in isolation and stir craziness in both introverts and extroverts? Is there a relationship, is there not, or maybe there's not a relationship between days in isolation and stir craziness for introverts, right? Introverts are totally fine no matter how long they have to stay at home. Or we could say, is there a different strength in a relationship or a different direction in a relationship between stir craziness and days at home for extroverts and introverts? So those would be our different conditions there. Okay, so here is what's called a grouped scatter plot of our data. Since it's fake data, you can see a very, very clear trend already. This is extroversion as a dummy variable. So we have coded our introverts as 0. And you can see their blue dots are down here, and our extroverts are coded as a 1. And so the red dots are up here. Days in isolation is our independent variable, and stir craziness is our dependent variable. So what you can look at in this chart right here is, first you can look at, you know, the overall scatter plot. If there were no colored dots on this plot, right, we would say that, okay, well, it seems like in general, the more you're in isolation, the more stir crazy you get. But since this is a group scatter plot and we have divided these dots by whether they were coded as an extrovert or an introvert, we can see a pattern in that our introverts, the group that's coded 0 on this extroversion variable, they have a fairly you know, slow increase in stir craziness for how long they're in isolation. But for our extroverts, they have a quite sharp increase in stir craziness for how long they're in isolation. We can look at this in different ways, right? And kind of see like, okay, well, you can see how extroverts, they already start a little bit more stir crazy up here, but they're not too different. But then by the time you get to 18 days in isolation, there's a lot of extroverted people who are up here and introverted people who are more down here. So we can already see a pretty clear trend just from looking at our scatter plot. So this is where you go through all your descriptives, all of those scatter plots, box plots, all those things are going to be helpful in helping you to understand the interaction term that happens later. So that's why it's a good idea to continue looking at your data even though our analysis is getting more complex. All right, so here's the process output for this type of analysis and interaction term, a moderation. And you notice that it's going to be very much the same as it has been. We get our model summary here, our R squared, our F, our degrees of freedom, and our p-value for the overall model. So we can say that this overall model is statistically significant. When we look at our constant, which is our intercept here, so this is, if we look back at our interpretations, when all the x's are 0, this is the mean for the reference group. So our reference group is the introverts. They were coded as 0. So what we can say is that when days in isolation are 0, right? So everything is 0. Days in isolation is 0. Extroversion is 0. So that means we're an introvert when we don't have any interaction. What we can say is that on the first day of isolation, 40 introverts, their stir craziness is at a 2.2866. Okay, so they're doing pretty good. And then when we look at this days in isolation slope, again, it's going to be the same as we've all been doing. This is our unit increases, right? Because it's a continuous slope. So 1 unit increase in days in isolation is related to a however many unit increase in stir craziness. And that's going to be in our reference group, which is a slight change from what we've been doing. So we can say that for each day in isolation, because this is a 1 unit, each day in isolation, stir craziness goes up by 0.4164. Okay, so that's sort of, the longer you're in isolation, the more stir crazy you get. Now, the caveat here is that this is going to be in our reference group because everything else is 0, so controlling for everything else, just like we've been doing. And then this is our dummy variable, extroversion, and we interpret that the same way we've been doing. So when controlling for the other x's in days in isolation, the group that's coded 1 is however many units higher or lower than the group that's coded 0. So these are our extroverts compared to our introverts. So on average, on day 0 of isolation, when our extroverts are going to be 1.8073 points higher on stir craziness than our introverts. So like we've seen before, our dummy variable is just telling us that mean difference between the extroverts and the introverts on stir craziness. So, our extroverts kind of start out a little higher on stir craziness, but we didn't really care about how they started out. We're interested in whether over that time of being in isolation, that stir craziness increases more rapidly for our extroverts than for our introverts. And that's where our interaction term helps us out. So here we go. This is our interaction term. Like I said, the number itself has meaning, but it's not all that useful for me to think about. If you want to know precisely what it is the difference in slope for the group coded 1 compared to the slope here. So it would be, if you were actually looking at the slope, you would see how you're just adding this number to that number, which is what process shows you, but I'm not going to go into that yet. We'll see that in our next example. But anyway, like I said, I just looked to see whether it's statistically significant. Yes, it is statistically significant. And what process does is it gives us some code to actually plot that interaction term for us. So before I show you that, I'm going to put this into an equation for you, right? So here's our dependent variable, intercept, slope for our dummy variable, slope for our continuous variable, and then that interaction term. So I'm just putting it here. Stir craziness starts out at 2.82866 for our introverts. Our extroverts are 1.8073 higher on average than our introverts in stir craziness. For each day in isolation, you're going to get 0.4164 more stir crazy, and then our interaction term is that difference in the slope for how much more stir crazy that our extroverts are going to be. All right, so this is what you call an interaction graph. When we have a significant interaction, what we do is we probe it, we graph it, we try and explain it. We try and draw straight lines for see who's doing what. It's basically the same thing as doing a fit line for the whole group, but instead of doing a fit line for everybody, we're doing a fit line for our two groups, our introverts and our extroverts. So as you can see, this looks very much like our scatter plot from before, but it's just one fit line for the extroverts here and one fit line for the introverts here. Okay, so the process of interpreting an interaction graph, you can approach this in a couple different ways. The first way that you can approach this is by treating each line sort of as a trend and saying, okay, I'm going to talk about what happens in the introverts, and then I'm going to talk about what happens in the extroverts. So if I'm going to treat it that way, I'm going to say, okay, let's take a look at what's going on in our introverts. They're the group that's coded 0 on this extroversion variable. What you see is that for our introverts, the longer they're in isolation, there is a positive relationship to stir craziness. So the longer in isolation, the more stir crazy they get. It's not a sharp increase though. You know, they start out about a 4 point something and they end up at about a, what was that, 7 something right there, 7 or 8. So, you know, introverts do get more stir crazy the longer they're in isolation. Okay, so that's the first group. And then our second group, we would say, okay, what's going on with the extroverts? Well, the extroverts, the longer they are in isolation, they also get more stir crazy. So they also have a positive relationship between days in isolation and stir craziness. But compared to the introverts, they get more stir crazy faster. So you can see they start out at about a 9. Yeah, they start out at about 8 or 9 or so, and then they go up to over 26, right? So that's it. Over those, you know, maybe, you know, let's call it 9 days in isolation, their stir craziness goes up about almost 15 or 15 points there, right? Whereas for the introverts, their stir craziness only increased like maybe 4 points over the 9 days in isolation. Okay, so we can see that there, in terms of our research question, do introverts and introverts differ in how quickly they become stir crazy? We can definitely say extroverts become stir crazy more quickly than the introverts. But you might also say that they started out more stir crazy. So this is somewhat meeting our expectations here. Okay. Now, that's one way to interpret an interaction graph, is to start with the groups and say, okay, this group goes here and that group goes there. The other way to think about an interaction graph is to compare the points along each, kind of at each point along this graph. Now, once we go over process, I'll talk to you about how these lines are plotted. You have to choose some numbers to put on here, but they provide these just convenient reference points for you to say, okay, let's start out with, you know, you're early in the isolation period. I'm going to compare the points and say introverts are less stir crazy than extroverts early on in the isolation period. But later on in the isolation period, introverts are still less stir crazy than extroverts, but extroverts have gotten that gap has widened. Okay, so that's one way that you could interpret this graph. Now notice the exact same conclusion as we came when we were interpreting it kind of line by line, but for some research questions, it's just a little bit more natural to sort of say, okay, they start out close together and they end up really far apart. So once we, once you kind of get into it, you'll get a feel for kind of how you like to interpret your interaction graphs. But those are the two ways. One is to just say, okay, how are these slopes? What are these slopes in the different groups? And then to say, how far or close to each other are they in on these different points? Okay, so that is the interpretation of an interaction term. So just to review a little bit, what's going to happen when you're interpreting these regressions that have moderation in them, intercepts and slopes, for the most part, are going to be very much the same. What changes is that interaction term. And we're not usually going to be interpreting that number itself directly, but we'll look at whether it's significant or not, and then we'll plot it or probe it in order to tell what's the pattern of results. All right, so we're going to pause there, and the next video will be kind of running it in a different software.